Welcome to Module 3 Protocols and Models. You know the basic components of a simple network as well as initial configuration. But after you have configured and connected these components, how do you know that they will work together or not? So, protocols are set of agreed upon rules that have been created by standards organizations. But because you cannot pick up a rule and look closely at it, how do you truly understand why there is such a rule and what is uh, supposed to do, right? And models give you a way to visualize the rules and their places in your network, right? So this module gives you an overview of network protocols and models. You are about to have a much deeper understanding of how network actually work. Our first objective is the rules. Basically, network vary in size, in shapes, and in functions. They can be as complex as devices connected to across the network, right? So, as simple as the two computers or two networks directly connected to one to another with a single cable, and anything in between. However, simply having a wired or wireless physical connection between end devices is not enough to enable communication. So, for communication to occur, devices must know that how to communicate. And people exchange ideas using many different communication methods. However, all communication methods have the following three elements in common. Number one is message source, means sender. Number two is receiver, means message destination. And number three is channel. Sending a message, whether by face to face communication or over a network, is governed by rules called protocols. These protocols are specific to the type of communication method being used. In our day to day personal communication, the rules we use to communicate over the one medium, like a telephone call, are not necessarily the same as the rule for using another medium, such as sending a letter, right? So the process of sending a letter is similar to communication that occurs in a computer network. Rule establishment. Before communicating with one another, individuals must use established rule or agreements to govern the conversation. Consider this message, this message. So notice how it is difficult to read the message because it is not formed properly. Like humans, communication between governs rule. It is very difficult. Means it is difficult to read the message because it is not formed properly. It should be written by rules like protocols, right? So that are necessary for effective communication. So another example below, the example shows the message which is now properly formed for language and grammar, right? So like protocol must account for the following requirements to successfully deliver a message that is understand by the receiver. Means a protocol should be an identified sender and receiver, and protocol should a common language and grammar, and its speed and timing of delivery, and confirmation or acknowledgement requirements, right? Now, network protocol requirements. Basically, the protocols that are used in network communication share many of these fundamental traits. In addition to identifying the source and destination, computer and network protocols define the details of how a message is transmitted across a network. Common computer protocols include the message encoding, message formatting and encapsulation, message size, message timing, and message delivery options. These are the fundamental protocol requirements. Now, message encoding. One of the first step to sending a message is encoding. Encoding is the process of converting information into another acceptable form for transmission, right? And decoding reverse this process to interrupt the information. So in this example, imagine a person calls a friend to discuss the details of the beautiful sunset. To communicate the message, she converts her thoughts into an agreed upon language. She then speaks the words using the sounds and inflections of spoken language that convey this message. Her friend listens to the description and decodes the sound to understand the message he received. And encoding between hosts must be in an appropriate format for the medium, and messages sent across the network are first converted into bits by a sending host, and each bit is encoded into a pattern of voltages on copper wires and infrared light in optical fibers and microwave for wireless system, right? So the destination host receives and decodes the signals to interrupt the messages. Now, message formatting and encapsulation. Basically, when a message is sent from source to destination, it must use a specific format or a specific structure, and message formats depend on the type of message and the channel that is used to deliver the message, right? So for example, a common example is requiring the correct format in human communications is when sending a letter, right? So an envelope has the address of the sender and receiver, each located at the proper place on the envelope, and if the destination address and formatting are not correct, the letter is not delivered, right? So the process of placing of message format means the letter inside another message format means the envelope is called the encapsulation, and another term is encapsulation. Basically, de-encapsulation occurs when the process is reversed by the receipt and the latter is removed from the basically envelope. Now, message timing. Basically, message timing is also very important in network communication, and message timing includes the flow control and response timeout and access methods and others. Basically, flow control, this is the process of managing the rate of data transmission, and flow control defines how much information can be sent and the speed at which it can be delivered. For example, if one person speaks too quickly, it may be difficult for the receiver to hear and understand the message. In network communication, there are network protocols used by the source and the destination devices to uh, the manage the flow of information, right? So other is response timeout. For example, if a person asks a question and does not hear a response within an acceptable amount of time, the person assumes that no answer is coming and reacts accordingly, right? So the person may repeat the question or instead may go on with the conversation. So basically, hosts on the network use network protocols that specify how long to wait for responses and what action to take if a response timeout occurs. So number three is access method. Basically, this determines when someone can send a message, and and basically it's collision of information occurs, right? And it is necessary for the two to back off and start again. Likewise, when a device wants to transmit a wireless LAN, it is necessary for the WLAN network interface card NIC to determine whether the wireless medium is available or not. Now, a note about the node icon. Basically, networking documents and topologies often represent the networking and end devices using a node icon. Nodes are typically represented as a circle. The figure shows a comparison of the three different delivery options using node icons instead of computer icons. So number one is unicast, multicast, and broadcast. We will study about this in next session. Now protocols. Basically, network protocols, you know that for end devices to be able to communicate over a network, each device must the same set of rules. These rules are called the protocols, and they have many functions in a network. This topic gives you an overview of network protocols, and network protocols define a common format and set of rules for basically exchanging the message between devices, and protocols are implemented by end devices and intermediate devices also in a software and hardware or both, right? So each network protocol has its own function, its own format, and its own rules of communication. And the it has various types of protocols that are needed to enable communication across one or more communication, like network communication protocol, network security protocol, routing protocols, discovery protocols. So basically, network communication protocols is enable two or more devices to communicate over one or two or more networks. The Ethernet family of technologies involves a variety of protocols such as IP, such as Transmission Control Protocol (TCP), and HTTP, Hypertext Transfer Protocol, and many more are the family of network communication protocols. And network security protocols, basically it secures the data to provide authentication, data integrity, and data encryption. For example, examples of secure protocols include the SSH, means secure shell, and SSL, secure sockets layer, and TLS, means transport layer security. And routing protocols are enable routers to exchange the route information and compare the path information, and then to select the best path to the destination network. Example of routing protocols including open shortest path, OSPF, and border gateway protocol, BGP. And number four is the service discovery protocols. Basically, service discovery protocols are used for the automatic detection of devices or services. Examples of service discovery protocols including DHCP, Dynamic Host Configuration Protocol, which discovers the services of IP address allocation, and also DNS, Domain Name System, which is used to perform name to IP address translation. Now, network protocols are responsible for the variety of functions necessary for network communications between end devices. For example, in this figure, how does the computer send a message across several network devices to the server? So, computer and network devices use agreed upon protocols to communicate. The uh, Basically, these functions are used for this. For example, addressing. Basically, addressing the identifies the sender and the intended receiver of the messages using a defined addressing scheme. Examples of the protocols that provide addressing including in Ethernet, IPv4, IPv6, and others. And other function is reliable. This function provides guaranteed delivery mechanisms in case messages are lost or corrupted in transit. So TCP provides guaranteed delivery. So TCP is the example of reliability. So number three is flow control. This function ensures that data flows at an efficient rate between two communicating devices, and TCP provides the flow control services. And other function is sequences. This function uniquely labels each transmit segment of data. The receiving device uses the sequencing information to reassemble the information correctly. This is useful if the data segments are lost, right? So TCP provides also the sequencing services. TCP provide the flow control. TCP provide the sequences services. We will discuss about the TCP in next module in details, right? So number four function is error detection. This function is used to determine if data became the corrupted during transmission. So various protocols that provide error detection, not TCP, but we can use the Ethernet, we can use the IPv4, IPv6, and also TCP. And application interface, this function basically contains the information used for process to process communication between network applications. For example, when accessing a web page, HTTP or HTTPS protocols are used to communicate between the client and server web processes. Now, protocol interaction. A message sent over a computer network typically requires the use of several protocols, such one with its own functions and format. The figure shows some common network protocol that are used when a device sends a request to a web server for its web page. The protocols HTTP is governs the way a web server and a web client interact. Basically, HTTP defines the content and formatting of the request and responses that are exchanged between the client and server. So both the client and the web server software implement HTTP as part of application. And also HTTP relies on other protocol to govern how the message are transported between the client and server. And TCP, transmission control protocol, this protocol manages the individual conversation, and TCP is responsible for guaranteeing the reliable delivery for the information and manage the flow control between the end devices. And internet protocol means IP. IP is responsible for delivering the messages for the sender and the receiver. IP is used by routers to forward the message across multiple networks. And Ethernet protocol is the responsible for the delivery of messages from one NIC to another NIC on the same Ethernet local area network LAN. Now, protocol suites. In many cases, protocol must be able to work with other protocols so that your online experience gives you everything you need to network communication protocols. So, protocol suites are designed to work with each other. And a protocol suite is a group of interrelated protocols necessary to perform a communication function. One of the best ways to visualize how the protocols within a suite interact is to view the interaction as a stack, and a protocol stack shows how the individual protocols within a suite are implemented. So the lower protocols of the stack are concerned with moving data over the network and provide service the upper layers, which are focused on the content of the message being sent. And as illustrated in this figure, we can use layers to describe the activity the occur in face-to-face communication. At the bottom is the physical layer where we have two people with voices saying words out loud, and in the middle, in the rule layer, that the requirements of communication including that a common language must be chosen. At the top is the content layer, and this is where the content of the communication is actually spoken. Now, evolution of protocol suites. A protocol suite is a set of protocols that work together to provide comprehensive network communication services. Since the 1970s, there have been several different protocols, some developed by standard organizations and other developed by various vendors. During the evolution of network communication and the internet, there were several competing protocol suites as shown in this figure. So in internet protocol suite or TCP/IP, this is the most common and relevant protocol suite used today. The TCP/IP protocol suite is an open standard protocol suite, and it maintained by IETF, means Internet Engineering Task Force. And other is OSI, Open System Interconnection Protocols. This is a family of protocols developed jointly in 1977 by the International Organizations for Standardization (ISO) and the International Telecommunication Union (ITU). So the OSI protocol layer also included a 7 layers model called OSI reference model, and OSI reference model categorized the functions of its protocol. And today OSI is mainly known for its layered model, and the OSI protocols have largely been replaced by TCP/IP. And number three is AppleTalk. AppleTalk, a short-lived protocol suite and released by Apple Inc. in 1995 for Apple devices. And in 1995, Apple adopted TCP/IP to replace the AppleTalk. And number four is Novel NetWare. It is a short-lived protocol suite and network operating system developed by Novell Inc. and in 1983 using the IPX network protocol. And in 1995, Novell adopted also TCP/IP to replace this protocol. TCP/IP protocol example. Basically, TCP/IP protocols are available for the application, transport, and internet layer. And there are no TCP/IP protocols in the network access layer. And the most common network access layer LAN protocol are Ethernet and WLAN, wireless LAN protocols. So network access layer protocols are responsible for delivering the IP packet over the physical medium. The figure shows an example of the three TCP/IP protocol used to send the packets between the web browser of a host and the web server. And HTTP, TCP, and the IP are the TCP/IP protocols used at the network access layer, and Ethernet is used in the example. However, this could also be a wireless standard such as WLAN or cellular services. Now, TCP/IP protocol suite. Basically, today the TCP/IP protocol suite include many protocols and continues to involve the support new services. Some of the more popular ones are shown in this figure, like application and others. So TCP/IP is the protocol suite used by the internet and network of today. TCP/IP has two important aspects of vendors and manufacturers. Number one is open standard protocol suite. This means it is freely available to the public and can be used by any vendor on their hardware on or in their softwares. And number two is standards based protocol suite. This means it has been endorsed endorsed by the networking industry and approved by a standard organization. This ensured that protocols from different manufacturers can the successfully. TCP/IP protocol suite is the various types, and we will discuss this topic in five or after five modules. So now TCP/IP communication process. Basically the animations in this figure, they demonstrate the complete communication process using an example of a web server transmitting data to a client. So look it. So go through this example and find it. Now reference model. You cannot actually watch real packets travel across a real network the way you can watch the components of a car being put together on a assembly line. So it helps to have a way of thinking about a network so that you can imagine what is happening. A model is useful in this situation. Like complex concepts such as how a network operates can be difficult to explain and understand. For this reason, a layered model is used to the operations of a network into manageable layers. There are the benefits of using a layered model to describe network protocols and operations. Number one is assisting in protocol design, because protocols that operate a specific layer have defined information that they act upon, and a defined interface to the layer above and below, right? And other is the fostering competition, because products from difficult vendors can work together. And number three is preventing technology or capability changes in one layer from affecting other layers above the below. And finally is providing a common language to describe the networking function and capabilities. So there are two layer model that are used to describe network operations. Number one is open system interconnection OSI reference model, and number two is TCP/IP reference model. So OSI reference model provides an extensive list of functions and services that can occur at each layer. This type of model provides within all types of network protocol and services by describing what must be done at a particular layer, but not how it should be uh, accomplished. So it also describes the interaction of each layer with the layer directly above and below. And the TCP/IP protocol discussed in this course are structured around both the OSI and TCP/IP model. So the table shown the details about each layer of the OSI layer and the functionality of each layer, and the relationship between layers will become more evident throughout this course as the protocols are discussed is in more details. Whereas the TCP/IP model layer are referred to only by name, the seven OSI model layer are more often referred to by number rather than by name. For instance, the physical layer is referred to as layer 1. The OSI layer model, data link layer is layer 2, and so on, right? Now the TCP/IP protocol model, basically this model for internetwork communication was created in the earlier 1970s and is sometimes referred to as the internet model. And this type of model closely machines the structure of a particular protocol suite. And this model is a protocol model because it describes the functions that occur at each layer of protocols within the TCP/IP suite, and it also used as a reference model. And this table shows the details about each layer of the OSI layer: application, transport, internet, network, access. So the definition of the standard and the TCP/IP protocol are discussed in public form, are defined in a publicly available set of IETF RFTS. And so an RFTC is authorized by networking engineers by sent to other members for the comments you can use there. Now OSI and TCP/IP model comparison. The protocol that make up the TCP/IP protocol suite that can also be described in terms of the OSI reference model. In the OSI layer model, the network access layer and the application layer of the TCP/IP model are further divided to describe the discrete functions that must occur at these layers. At the network access, the TCP/IP protocol suite does not specify which protocol to use when transmitting over a physical medium. It only describes the handoff from the internet layer to the physical network protocol, and OSI layer 1 to discuss the necessary producers to access the media and the physical means to send data over a medium. So the key similarities are in the transport and network layer. However, the two models are differ in how they relate to the layer above and below each other. So SI layer 3, the network layer, maps directly to the TCP/IP internet layer. This layer is used to describe protocol that address and route messages through an internetworks. And OSI layer 4, the transport layer, it maps the directly to the TCP/IP transport layer, and this layer describes the general services and functions that provide ordered and reliable delivery of data between source and destination host. And TCP/IP application layer includes several protocols that provide specific functionalities to a variety of end user applications. The OSI model layer 5, 6, and 7 are used as reference for the application software developers and vendors to produce the applications that operate on networks. And finally, both the TCP/IP and OSI models are commonly used when referring to protocols at various layers. Because the OSI model separates the data link layer from the physical layer, and it is commonly used when referring to these basically lower layers.